All right, let's talk about the future of quantum technology. We're going to use the McKinsey Quantum Monitor report, pretty much the best guide out there, to map this whole landscape. But we're not just reading a report, oh no. We're going to use it to hunt for something that just maybe even McKinsey overlooked. Something hiding in plain sight.
First things first, let's get a sense of scale. McKinsey is projecting that the quantum tech sector could be worth up to $131 times billion by 2040. Yeah, this isn't just some niche market. We are talking about a fundamental technological revolution with a massive, massive economic footprint.
So with a market that huge, the big question becomes, where do you place your bets? I mean, where is the real value going to come from? Is it in building the quantum computers themselves, the little components? Or is it something else entirely? This is the central question for anyone trying to navigate this space.
To answer that, we've got our map, right? The McKinsey report. It is the best guide we have. But our whole investigation today is built on a really fascinating idea. What if the map, as good as it is missing something? What if there's an entire category of innovation that's just not on it?
Okay, so our investigation starts by following the first major clue that the report gives us. And it's a really big one, a fundamental shift in where the value is actually being created in the quantum industry.
And here's the clue, straight from the source. You know, the early days of quantum were all about the hardware, building the actual machines, but now McKinsey says the value is shifting over to the software, the applications that can use these super powerful machines to solve real-world problems. Basically, the value is moving from the physical box to the useful work that the box can actually do.
And this shift from hardware to applications, that's where the real opportunity is. So imagine a system that isn't focused on building one specific piece of hardware, but instead, it's about creating a marketplace for the quantum work itself. A network that could use the powerful GPUs we have today to start doing that valuable work right now. It creates this application layer that can sit on top of any future hardware. This is exactly the kind of innovation that fits perfectly with the trend McKinsey is pointing to.
This brings us to the next huge challenge in the quantum world. See, there's this massive gap between the powerful classical computers we have right now and the truly mind-blowing quantum computers of the future. Let's dig into how we can build a bridge across that gap.
Here's the problem in a nutshell. On one side, we have these incredibly powerful GPUs. They're the workhorses of AI, of high-performance computing. On the other side, we have the promise of quantum computers, which, let's be honest, are still pretty immature and really prone to errors. These two worlds, they don't connect very easily, at least not yet.
This is where a really clever idea like quantum proof of work, or qPoW, comes into play. So instead of having computers solve, these abstract math puzzles just for network security, this concept says, let's use all that computational power to run useful, valuable quantum simulations. It's a way to harness the classical hardware we have today to do the kind of work we expect from tomorrow's quantum systems. It literally creates a bridge between them.
And this model creates this dynamic, totally future-proof bridge. It starts right now, today, with miners running quantum workloads on their GPUs. Then, as the actual quantum computers get better and better, the complexity and the utility of these mining tasks can scale right alongside them. And finally, this is the cool part, when mature quantum hardware is ready, it can just plug directly into this marketplace for quantum jobs that already exists and is already working.
Okay, so we have a system that can do quantum work. But is it doing the right work? Is it focused on the applications that are actually going to be valuable? Let's check McKinsey's treasure map and see where X marks the spot.
According to the report, the real value, the real money, is in a few key areas. First, simulating molecules. Think pharma, drug discovery. Second, accelerating AI and machine learning. Third, solving incredibly complex optimization problems for things like finance and logistics. And finally, designing totally new materials, atom by atom. These are the billion-dollar applications.
And here's where it all clicks into place. The most valuable quantum applications that McKinsey identified, molecular simulation, AI, optimization, these are precisely the kinds of simulations that a qPoW network, like the one Qubitcoin is building, is designed to run. So the network isn't just doing some abstract work, it's doing the right work, the most valuable work, right from day one.
Technology isn't built in a vacuum. The next piece of our puzzle is all about geography and community. Being in the right place, with the right people, that can make all the difference in the world.
A project like Qubitcoin comes directly from the heart of the world's top quantum computing cluster, Boston. We're talking a founder from MIT who collaborates with Quera,
a company McKinsey itself points to as a breakthrough player. This isn't some random project, it's born from the absolute epicenter of quantum innovation. And this whole ecosystem is about to get supercharged. Governments all over the world are pumping over $10 billion into quantum R&D. This flood of capital is going to create a huge demand for computational resources and a need for coordination. A neutral, decentralized platform that can verify and hand out quantum workloads could become the essential infrastructure to manage all of that investment.
So it's time. Let's put all of these clues together. We've followed the value shift, we've looked at the tech bridge, the specific applications, the ecosystem. Let's see what the full picture looks like.
When we just line this concept up against McKinsey's key trends, the alignment is, well, it's pretty staggering. The report says value is shifting to software. This is a decentralized application layer. The report highlights monetizing early. A marketplace for quantum work does that by its very nature. The most valuable use cases McKinsey points to, they are the mining algorithm. And it even comes from the Boston Innovation Cluster, the report singles out. It's a concept that hits every single major trend head-on.
So, we come all the way back to our original question. What was missing from McKinsey's map? Well, maybe it's an entirely new category, one that isn't just hardware or just software, but a fusion of both. A decentralized marketplace for quantum computation, powered by the incentives of a blockchain that ties all the individual pieces of the quantum ecosystem together.
And that leaves us with one final, pretty fascinating question to think about. By turning computational work into a decentralized market, are we quietly watching the birth of the world's first truly quantum economy built on a blockchain foundation? It's a powerful idea for sure, and it's one that could completely reshape the quantum future.